Hey there, Dr. Callahan here for week 1 Friday. So go ahead and answer these 3 questions for your warm-up. I'll be back on Friday and I will give you guys the warm-up log. So for the time being, just go ahead and answer these questions on a separate piece of paper and you will get the points for it. Okay, so when I saw you guys on Thursday, these were some of the questions that we went over. You should have completed them. And if I was in class, I would totally ask you guys if you have any questions. However, if you do need some additional assistance in terms of, like, let's say factoring trinomials, factoring sums and differences of cubes, adding, subtracting, and dividing rationals, dividing polynomials, graphing a line in y and standard form, writing an equation of a line in y-intercept, point slope form, and standard form, I have some links here of videos that you can go to. Do keep in mind that you do, however, need to know how to do these things from Algebra 2 Honors and Pre-Calculus. Okay, so this is the breakdown of what we're going to be talking about today. Today we're going to talk about symmetry. There we go. Symmetry. You're going to go over my notes on symmetry to the x, y axis, and origin. I do have a Kahoot right here that determines the even, odd, or neither. You can go and click on that link or type it in and then work on that. And your homework starts with sections 1.1 on Math Excel. And if you just go to the link for Math Excel from the district website, you will have access to it. All of your assignments are going to be due on Sunday by 11 p.m. So even though this is week 1 Friday and next week is going to be week 2 Monday, all of your assignments for week 1 Friday, week 2 Monday to week 2 Friday is going to be due on this coming Sunday by 11 p.m. Since we're starting with 1.1 on Friday, it didn't make any sense to have a due date on Sunday, so make sure you guys have that. You can, however, turn late work in, but you will have a 40% deduction on it. All right, let's go ahead and take a look at our notes, your guided notes for today. If you go to week 1 Friday, your guided notes is going to be on the very bottom here. Okay, we're going to go over our notes on this page right here. So this is your guided notes with me. And we do have a few practice problems here. These are a few practice problems that's kind of aligned with the assignments we're going to go over in class. I do have a algebra puzzle here that says, what do you call 2 spheres that are symmetric to each other with respect to the origin? And you're just going to go ahead and write down the answer. Also, I have some of my notes when it comes to symmetry. And if you need some additional practices, I do have some more notes here with examples. But in addition to that, I also have the answers attached as well. Okay, so you can practice a little bit more with that. All right, so with that said, let's go ahead and get started with today's stuff. All right, so we're going to start off right there where that little arrow is pointing at, so you guys can see where it is. Okay, so looking at this right here, it says graph y equals x squared minus 2. And it says construct the table. So it's going to be pretty simple. So every time you see an x, you're going to replace the x with a -2. So my first one is y is equal to -2 squared minus 2. And as you know, -2 times -2 is going to be a +4 minus 2. So y equals 2. So your first point here is going to be a -2, comma 2. Second point is a -1, so y equals -1 squared minus 2. -1 times -1 is a +1, minus 2 is a -1. So my second point is -1, -1. Third point, y equals 0 squared minus 2. Y equals 0 times 0 is just 0, minus 2 is going to give me a -2. So my third point here is going to be a 0, comma, -2. And you can keep going with this. Y equals 4 plus 3, so you're going to have a 7, 2 comma 7. And same thing for the next one, y equals 9 minus 2. You know, I don't know why I put plus 3. That's kind of weird. Okay, hold on. Let's backtrack a little bit. Okay. Uh-oh. So let's backtrack a little bit. It's actually supposed to be a minus. I'm not quite sure why I did that. So you have 4 minus 2. So y equals 2. So it should be a 2, -2. And the last one is y is equal to 9 minus 2, so y equals 7. So I just jumped ahead a little bit. So 3, comma 7. So you guys have 5 points that you can go ahead and graph. And if you take a look at this right here, we can go ahead and graph it. In which case you have -2, +2. So right there is your first point. -1, +1, 0, -2. And then I have 2, -2, 1, 2, 1, 2. And then I have 3, 1, 2, 3, 4, 5, 6, 7. If you take a look at this right here, it kind of looks like a shape of a parabola. Well, because I know that there's y or x squared, so my graph looks something like this. Mine's a little bit off, but the actual graph looks like this. All right, let's go ahead and move on forward. So then we have the next part right here. And I'm going to have you guys just work on this one by yourself. You should know that it's a straight line. These are your values. You have 0, 7, 1, 4, 2, 1, 3, -2, 4, -5, and you should construct a straight line. So here's a bonus question. You know it's going to be in a shape of a parabola. The 3 here means you're going to go up 3. -1 means you're going to go 1 to the right side. And you know it's going to be an happy phase because it's a positive in front of A. So if I were to go ahead and graph this, I would go up 3. From there, go over to the right one. And you know it's going to be a parabola like this. Okay, so what do you notice about these 4 graphs? What do they represent? How are they different? And make sure you're able to identify the x and y intercept. All right, example 2. For example 2, it says, find the x and y intercept of y equals x cubed minus 4. All right, so let's take a look. Here are the steps. Number 1, let y be 0. So 0 equals x cubed minus 4x. Done. Factor it out. Well, I could take out an x right here, so x squared minus 4. I also know that this part right here is a special factorization, so I can do an x plus 2, x minus 2. Solve for x. So if I set this 0 to x, x equals 0. If I set x plus 2 to 0 and I solve for it, it will be a negative 2. And the same thing if I set x minus 2 equals 0, it will be a positive 2. So right here, what I have here are my x-intercept. Now, if you were to look for the y-intercepts, you would, and actually here, the x-intercept is when y equals to 0. So my x-intercept is going to be 0, 0, negative 2, 0, 2, 0. Now to find my y-intercept, I have to set the x equal to 0. And if I do that, y equals 0 cubed minus 4 times 0. So y is equal to 0. So for my y-intercept, it's just 0, comma 0. And there you guys have it. Here are your x-intercept, and you have 3 of them. And here are your y-intercepts. It's just one of them. If you're to go ahead and graph that on your calculator, I generally like to use Desmos.com. It will look something like this, and if you look at it, you do have your x-intercept right here at negative 2, 0, 0, 0, 2, 0, and you also have a x-intercept, I'm sorry, a y-intercept at 0, comma 0. All right, next thing we're going to talk about is symmetry, okay? So if something is with respect symmetric to the y-axis, xy is a point on the graph as negative xy. And if you think about it, if I have a point at 1, 1, okay, and if I go ahead and reflect that over the y-axis, and this is a y-axis, what changes on this point? It looks like it becomes a negative 1, 1, which makes sense because xy becomes a negative x, positive y. So this is when something is symmetric with respect to the y-axis. And that's generally how I kind of visualize it. Now, on the other hand, let's go on to the next one. If xy becomes x negative y, so here's my graph, and let's just use the same point, 1, 1, okay? And that's xy. I don't like having that little dot there. It always screws things up. Okay, here we go. And let's say I'm going to take that and I'm going to reflect it about the y-axis, or I'm sorry, the x-axis. So I'm going to take this point and boom, flip it over here. If you look at it, what changed? Well, my x is not changed. It's still at 1, but my y certainly did change. It's now a negative 1. So then you know that if your answer results in an x negative y, it is with respect to the symmetric to the x-axis. Next, you have if xy changes in negative x and negative y, then this means that it is respect to the origin. So if I still use 1, 1, essentially what it means with reflect or symmetric to the origin means that it's going to reflect on the x-axis, then reflect on the y-axis. So let's try that. If I'm going to have those reflected on the x-axis, I move this over here. So it is at 1, negative 1. So you can see xy becomes an x negative y. Okay, and this is reflect on the x-axis. However, because it's with origin, you have to reflect on the x-axis, then the y-axis. So here's the y-axis, and I'm going to flip it over this way. If you look at the new one, this one here is going to be negative 1, negative 1. Okay, and so what happened here is I have a negative x and a negative y. And this is how you make the determination that it is reflected about the origin, because you flip it over the x and then flip it over the y. So look at these three diagrams. Which axes are they symmetric to? All right, we're going to be right over here. Okay, so let's go ahead and take a look at this question right here. We're going to see which one it is symmetric to. So I'm just going to start off with the first one, and it is if it is symmetric with respect to the y, if replacing x by a negative x yield equivalent equation. Okay, so let's do that. So I'm going to replace my x with a negative x. Y equals 2 negative x to the third minus negative x. So this is an odd, okay? Remember back in trigonometry and pre-calculus, if you have an even power of a negative, you will get a positive x. If you have a negative x to an odd power, it will be a negative x. And that makes sense because if you have negative x to the third power, you have negative x times negative x times negative x. Negative times a negative is a positive, but that positive times a negative, guess what? It's a negative. So you have a negative x to the third power, okay? So here I have negative 2x to the third power. Here, negative times a negative is a positive x. Now, does this give me or match up to the original equation? And the answer is no, because I have a negative and a positive x. So it is not respect to the y-axis. So boom, go ahead and cancel that out. Now let's try the next one, 2. I'm going to replace the y by a negative y, and if that gives me an equivalent equation, then I know it's respect to the x-axis. So let's try that. So I'm going to replace the y with a negative y equals 2x to the third minus x. Well, I want to put this back into the original equation, so I need to multiply by a negative 1 on everything to balance it out. Double negative is a positive y. This becomes a negative 2x to the third positive x. Now, does this give me to the original equation? And the answer is no. So what does that mean? That means it's not respect to the y-axis. So what does that mean then? That means it is going to be respect to the origin. So we crossed out first one, crossed out second one, it has to be the third one. And actually, how do you know if it is going to be the third one? Because if you look at this right here, it says if you replace the x by a negative x and you replace the y by a negative y, and therefore I'll give you the equivalent equation. Well, let's go ahead and take a look at that. Okay, so let's try the last one. So I'm going to replace that y with a negative y. Replace that x with a negative x to the third power minus negative x. Let's see if that yields to the original equation. So I have a negative y equals, we determined that this is going to be an odd, so 2x to the third plus x. Now, I want the original equation, which means I have to change the negatives here. So I have to multiply by a negative 1 on all three. Negative 1 times y gives me a positive y. Negative 1 times a negative 2 is a positive 2x cubed. Negative 1 times x is a negative x. So as I look at this original equation here with my equation, do they match? Yes, they do. So what does this mean? That means it is symmetric with about to the origin. So since replacing xy with negative x and negative y resulted in the same original function, I conclude the function is symmetric to the origin. All right, next one right up here. Okay, so is this symmetric to the x-axis? If I were to go ahead and do that, I would replace the y by a negative y. So let's do that. Negative y equals 4 minus square root of x plus 3. I don't want to have a negative y, so I'm going to multiply everything by a negative 1, which means I have a positive y equals a negative 4 plus square root of x plus 3. So is it? Nope, this is not the original equation. It does not match. So it is not symmetric to the x-axis. Well, let's go ahead and try something else then. Let's try maybe see if it is symmetric to the y-axis, which means I'm going to replace the x by a negative x. So y equals 4 minus negative x plus 3. Well, this is still not the same, so no match. So it is not symmetric with respect to the y-axis. So that's a no-go. Last one to try is the graph of the equation x and y is symmetric with respect to the origin if I replace the x with a negative x, y with a negative y. So let's try that then. So if I replace the y with a negative y, 4 minus negative x plus 3. So I want to counter that negative by multiplying everything by a negative 1. So I have a positive y equals negative 4 plus square root of negative x plus 3. So as I look at this, is this the same as the original? Uh-oh. Nope. So I can't say that this is symmetric to anything. So then it's just not symmetric, and therefore it is neither. So since replacing x and y to negative x, negative y, x and y to x and negative y, and x and y to negative x and positive y, and it did not result in the same original function, I conclude the function is neither. And that's what you will say. All right, example 5. Find all points of the intersection of the graph x squared minus y equals 3 and x minus y equals 1. So I have the steps right here. Number 1, solve the first equation for y. So this is your first equation. I'm going to solve for y. Negative y equals, move the x squared over. We don't want a negative, so I'm going to have a positive x squared minus 3. Second step, solve the second equation for y. This is your second equation. Negative y equals negative x plus 1. Y equals a positive x minus 1. Okay? Next step, number 3. Equate y values. So now that I have both of these as y values, I'm going to take what y equals and set them equal to each other. X squared minus 3 equals x minus 1. Write in general form. Okay? So I'm going to move everything from the right side over to the left side and set it equal to 0. So I am going to have an x squared minus an x plus the 1's give me a negative 2 equal to 0. Next step, factor. Okay? I'm going to ask myself, what times what gives me a negative 2? When I add it together, it gives me a negative 1. I could do a negative 2 and a positive 1. Last step, solve for x. X equals a positive 2. X equals a negative 1. Have you guys noticed that my handwriting has gotten significantly better with practice on this? And that is going to be my intersection. So my intersection is going to be at when x is equal to negative 1, I'm going to have y equals 2. When x is equal to 2, I'm going to have y equals 1. And those are my intersections. You guys can go ahead and practice with 61 and 63. You're going to find the point of intersection. So you're going to do exactly the same thing I did with the following steps. Number 1, solve for the first equation for y. Number 2, solve the second equation for y. Number 3, equate both y values. Number 4, write in general form 8x plus by equals 0. Or actually, I should put plus c as well. Whoops, hold on, let's go back to that. Plus c equals 0. Step 5, factor it. Step 6, solve for x. If you would like to take a look at the answers, here's my answer for number 61. All right. So at this point, you guys can go ahead and take a look at my notes. You can go ahead and practice with the even and odd with this calculus puzzle. You could do some additional practices here, or you can go over the notes a little bit more in depth using this guided notes right here. Have a great night, you guys.